What's going on, you guys? Mr. Allen here, about to write some trig functions to match these two different graphs that we have here. And we're going to write sine and cosine functions for each one. You might be like, wait, what? You don't just pick one of them? You can actually write an infinite number of functions, both sine and cosine, to match these things right here. Okay, I'm going to show you. It's going to be dope. All right, so first one here. I want to identify what my period is. Okay, so when does this thing repeat? I think it's easy to look for two high points here. We got from 0 to 4, so my period is 4. I'm just going to jot that down. Period is 4. Okay, and I can use that to figure out what my period multiplier should be, right? If I want to get what my period is, I would do 2 pi divided by b. And I can do the same thing here, but with my period, 2 pi divided by 4 is going to give me that multiplier, okay? So if I do 2 pi divided by 4, I get what, pi over 2? So that's going to be my period multiplier. Think about it. If I did 2 pi divided by pi over 2, multiplied by the reciprocal, the pi's cancel, I'm left with 4. Oh my goodness, I get my period. Okay, cool. So 2 pi divided by b, or 2 pi divided by what my period is, will give me that multiplier. It's kind of nice that they work out the same. Lovely. How about midline? I like to do that as well, right? That's important for both sine and cosine. So we got our midline there at -1. So I should see a -1 here. My amplitude, it's looking like 1, 2, 3. So 3 is my amplitude. I'll write that down. Amplitude 3. And then I feel like we could probably get to work from there, okay? So for sine, let's start with our, actually, I'm going to start with my cosine graph. I think it's a little bit easier with the cosine graph because you may notice that here I'm starting above the midline, which is how a cosine graph would start, and no phase shift. That's kind of nice. So y equals cosine. Actually, hold up. I should probably have a 3 in front there. We just wrote that it has an amplitude of 3, and I'm already forgetting to write that down. Come on, Mr. Allen. Come on. Come on. All right. Here we go. So we got y equals, take 2, 3 cosine. Then I have pi over 2 is my b value here, so pi over 2. We said there's no phase shift, so we're just going to throw in theta, close them, and we went down 1, so -1. Nice. There's one in the bank. I started up here with the pink one there, and then my cosine graph goes like that. Okay, cool. How about a sine graph? Well, where can sine start? It's got to start on the midline. That was a good voice crack. I'm going to leave it in there. It needs to start on the midline, right? Now, I can either start right here, and then it's going up, which means it's positive, or I could start here, and then it's going down, all right? Let's start with the one that I already circled, okay? And then we'll explore some of the other options here because it is kind of interesting that you can do really an infinite number of these, okay? So, Katoa, we're going to go with y equals, it's still going to be 3, and since I'm going up, it's positive 3 sine. We've got our pi over 2 here, but I do have a phase shift of moving to the left 1, so I'm going to open up another set of parentheses. Then we got our theta. If I'm going to the left 1, it's going to be +1. Close them, close them. Oh boy, don't have a ton of room here. And then we got to be down 1, so -1. Okay, that got kind of messy there. I apologize, okay? So, wonderful. We got it. That's dope. That's awesome and fantastic. So we got ourselves the same amplitude here. You're going to see that being the same. Sometimes it's positive, sometimes it's negative based on what's happening after, right? We have our same multiplier. That's going to be the same in either sine or cosine function here, all right? And so is the -1 out here. Those things are going to be the same. The changes are the phase shift, no phase shift, and if it's positive or negative, could change as well. Let's do another one. Let's do another with this graph, okay? I did state something about starting with this point here, and I will maybe do that one right up here. So this is starting on the midline, which means it's a sine function, okay? So if it's starting on the midline, that's a sine function, but it is starting by going down. So really I'm looking at, if I were to outline this, I'd be going like this, on up, boom. That part right there is what I'm doing. That'd be one period of the function I'm about to write. So we're going to have y equals -3. So 3 is still my amplitude, all right? But it's negative because it's going down first. Then I have sine. My period multiplier is the same every time. But I do have a phase shift, this time to the right 1. So it's -1. Close them, and then we move down 1 for that midline. So there's that one. Cool. Awesome. This green one here, if I were to outline it all, it'd follow along like this. Don't want to go too far. That's the full period of the green one. Okay? And then this pink one here, this cosine original, right? That original one. This is my full period of that pink one. Let's do one more cosine graph, shall we? One more cosine? I think we shall. So I got options here. Because I'll be able to outline more of it, I'm going to go back to this point right here. Okay? And this cosine graph will be like, follow from low point to low point. This is looking pretty dope. I like all the rainbowy colors here. All right, so we got y equals, this time since I'm starting below the midline, it's going to be -3 cosine. And then I have the same multiplier, but I do have a phase shift. I'm going to the left by 2. So we have pi over 2 theta plus 2, close them, -1. Cool. I like that. It's awesome. It's fantastic. There we go. If you wanted to be like a real nerd here, here's what you could do. Let's say I want to start the pink one there, but like I want to do like a crazy phase shift, because why not? We could even say like y equals 3 cosine of pi over 2, and then we could do theta. And if I wanted to shift, I could just shift this thing by a multiple of 4, right? Because it's gonna just bumped my knee. It's gonna move 4, and then it starts over 4, 4, 4. So I could be like plus or minus or whatever. I could shift it this way or that way, right? We do 512. That's a multiple of 4. -1, right? Cool. And then they'll be like, bro, what? Why would you do that? And be like, am I wrong? And you get some mathematical sass going. Don't be too sassy. Don't be too sassy. All right, but you could do that if you wanted to. If you wanted to. All right. Next one down here. Okay. This thing is shifted down, which leaves me nice room right there to write some things. It's like I planned that. Okay. Let's go. Let's do this. Let's get after it. First one here. Well, I'm going to pop in my midline here. It looks like it's here at -2. What's my period looking like here? I think it's usually easiest to go from high point to high point. People tend to screw up when they're looking at it from the sine, like from midline to midline. They're like, oh, it's from here to here. No, it would be to here, okay? But I'll go high point to high point. It looks like it's pi this time, okay? So period is pi. All right. And then let's see here. What else do we need? Amplitude. Amplitude's 2. Okay? And then phase shifts we'll decide after the fact. It looks like, once again, it's actually going to be easier to write our cosine function first. Let's just do that, right? That's above the midline. It's positive, easy peasy. It's going to be this stretch right here would be the full, period right there to there. So we'll go with y equals, and it's an amplitude of 2, so 2 cosine. It's a big C because I started making a parenthesis on accident. Cosine. Oh, I didn't get my period multiplier, right? I'm going to take the period. I'm going to take my normal 2 pi period, divide it by the actual period. It gives me my multiplier of 2. Okay. So then it's going to be 2 right here. No phase shift, so theta. Don't need the extra parenthesis. My goodness. My goodness. Let's erase that parenthesis there. Too many. That giant C threw me off, which I initially was going to make a parenthesis. Okay. And then we're shifting it down 2, so -2. That's a lot of 2's there, unfortunately. All right, this 2 is because of the amplitude of 2. This 2 is the period multiplier to get us a period of pi. And this 2 is because we moved it down 2. Lovely. All right, next one. I'm going to go with sine, and the easiest sine will be shifting it back right here. So that would be this stretch of the function. Boom. That right there is one period of the function I'm about to write, which will be y equals, it's positive 2 because I'm starting by going up, sine. This time I'm going to have a phase shift. So I have 2 parentheses, and we're shifting by pi over 4. So it's going to be theta plus pi over 4, close them, -2. So again, this is going to stay the same, possibly change sign, positive or negative. This guy will always be the exact same. This guy will always be the exact same, but the phase shift can change as well. Okay, so the negative out front can change, if there is one or not, and the phase shift can change. The other stuff will remain the same, okay? Uno mas? Let's see. Hey, if you're still like, hey, man, can I do another one? You know what? Let's do, I think this is good. I think this is good. right? We did one cosine, one sine. That's usually what they'll ask. They won't ask for too many of these things here. And I feel like this video is probably getting a little long anyways. We're at 10 minutes. Yeah, that's good. We'll cut it off there. But you could keep going. You could keep going if you wanted to. But that's about it. All right? Awesome. Fantastic. Wonderful. Dope. You guys are dope. All right. Have a great day.